So I'm working away at marking your tests. So far they look pretty good. Got through about a quarter of them, I believe, and I'm very pleased with what I'm seeing so far. So good work to the random sample of your tests that I've already looked at. No guarantees for everybody, but they're pretty good. So I am hoping to get your marks uploaded this weekend and then be able to hand your tests back to you on Tuesday of next. Wait a minute.
Wait a minute, indeed.
We have a break? Okay. I'm going to have to revise that plan of when I'm going to hand back your tests. It's going to be really tough for me to get them by Thursday. I can hold office hours during the break if you want to come pick them up. So I think that's the best plan. One way or the other, my goal is to get your marks up this weekend. I take it that that's the main number that you're interested in. So, yeah.
If we don't get it during the break, will you hand them out during the next class?
Yeah, totally. So if you don't come pick them up during the break, I'll bring them to the class after the break. Yeah, in case you're not burning to know which marks came from which questions. So, also, the topics for the first essay are posted as of this morning. I take it that there's one fairly generic one about categorization, prototype theory, one about memory, one about attention, and then I just this morning decided that I would offer you the option of writing a topic of your own choosing. So if you don't like any of the topics that you see there and you have one in mind that you think would be more interesting for you to write, all I ask is that you run it by me either in person or over email during office hours, wherever you can. So that's a wide open, like whatever from the beginning. It's got to be related to the course, of course, but if it's something that you're interested, if you've got something that you were hoping to write and you don't see it in the list of topics, just talk to me. Okay? And we'll talk on Thursday a little bit of it. I propose to do a very brief overview of doing the kind of research for this paper that you'll need to do. So we'll look at some good databases and ways of crawling through the network of sources and strategies and that kind of thing. We'll just do a short thing, but if that sounds good. Okay, any questions about either of those things? No? Okay. So we have finished psychology, the first kind of third of the course. We're done it. I want to kind of very briefly review what we said, or try to extract at the highest levels the kind of most important themes and things that I'd like you to take away from it. So of course we did categorization, memory, problem solving, and I proposed to you that there are a few things that come out of all three of those sections. In categorization, the hardest part about categorization seems to be that we do it flexibly and dynamically. You don't just categorize things once and you're done. If we did that, then it would be fairly straightforward to represent in a formalism just our assessments of how things fit into categories and just call it a day. But it looks like that's not what we do. And in fact, that's not what we want to be doing either. So we do things like judging things to be more or less similar based on context or based on theories or ideas that we have. And we do that so that we can categorize things in a way that helps us solve our problems. So that's problem solving appearing at the heart of categorization. Something very, very similar happened in memory. So we found that you don't just take in sense data and store it and bring it back up later when you need it. What you do is you code things in a way that lets you transfer them to new situations. We called that transfer appropriate processing. And again, we want to be like that. I recommend that we want to be like that because that's the way we store things in order to help us, once again, solve our problems. You recall the stuff about two little boys. There's a story about two boys playing in a living room. And if you have one perspective on the story, you remember some things. And if you're given a different perspective, you'll remember different things. That's what we want our memory to be like because we want to be able to not have to sort through every single thing that ever happened to you in your life. You take a perspective on the things that have happened to you. And that perspective taking seems to be a hard thing to explain. It's a kind of, without understanding how you choose the perspective, we're probably not going to deeply understand long-term memory. So again, problem solving shows up in memory. And then we did problem solving, where this perspective taking thing comes up again. Some problems are obviously really straightforward. I hope that you have the opening the door of your home problem pretty much solved. You do it pretty much the same way every time. It's kind of invisible to you as a problem. Some problems are straightforward but visible, like doing math, doing logic, playing board games. Those should be like, they're problems, but they're not problems where you have to like rethink your life in order to solve them. But then there's of course insight problems where we need to do this perspective taking and perspective breaking thing where you have a view of a problem and then you have to give it up and find a better view. And we saw that that was probably going to be the hard part to explain in problem solving, and once again it drew us to the problem of deciding what's relevant, deciding what to put inside your frame and what to exclude from it. And so here's two things that I wanted you to take out of this, and I know I've been hammering away at this, but I think it's helpful to just do these things several times. So in all three areas, we found the need to figure out what's relevant. So realizing relevance, recognizing what's relevant to you in a situation is how we cope with the finitary predicament, the fact that the world is way too complex for us to take it all in. And relevance seems to be particularly hard to pre-specify with rules. So it's really difficult, if not impossible, to say ahead of time what's going to be relevant. Human level cognition seems to be precisely cognition that's able to take context into account. That is, we're able to look not just at rules, but in fact take the exact situation that we're in and deal with it as a situation rather than dealing with it as a class or an abstract class of scenarios. So being an intelligent human means being able to decide which rules are relevant more than just following some set of rules. And that led us into this kind of like, so we saw this in the insight problem solving stuff, a kind of two different ways of thinking about cognition. One as a rule-based activity, that is, what is thinking really? It's really just using language-like representations and applying rules of transformation to those language-like representations. That was the assumption of the Newell and Simon project. It's been the assumption of a lot of cognitive psychology for a long time. And then I started at the very end suggesting that maybe there's another way we can think about this. So some systems don't seem to operate according to language-like representations and their transformations according to rules. The Watt governor was one. It seems to do something, I don't know if you want to call it intelligent, but at least does something smart looking without seeming to need any kind of internal representation. So maybe we're more like the Watt governor than a computer. This is kind of a rule-based versus dynamical cognition, which I told you that we'd be looking at when we get into AI. And indeed, we're going to do that. Okay, so I take it we've been over that a lot. Good so far? Okay, I'm going to do something mildly different here. I would like to do a preview of what we're going to get through, what we're going to do in the next section. So just really briefly preview how the AI chunk of this course is going to go. So that you know where we're going, and maybe the reasons why I've been highlighting all these things will become a little bit clearer. So we're going to start out by today we're going to start out, today's going to be an odd one. We're going to do a bunch of history, which I will probably not strike you immediately as relevant to artificial intelligence, but I promise you that it does connect up. So after we've done today, here's what we're going to do. We're going to start by looking at what's called good old-fashioned AI, or GOFI, they sometimes call it. And this is a paradigm of AI research in which they make precisely the assumption that we were just talking about, that cognition is language-like manipulation of symbols according to rules. The kind of thing that your computer does. And in fact, their primary metaphor for what the mind is a computer. This is a really common thing, by the way. People think about the mind in terms of whatever the fanciest technology available is. Before computers were big, people said it was like a telephone switchboard. Like when you used to call somebody on the telephone, a person had to hook up one wire into your connection and one wire into the person you're trying to call. So like the mind is like a switchboard. And then the mind is like a computer. And now we have parallel computers. So the mind is like a parallel computer. So at every age, whatever the fanciest technology is, that's what we think the mind is like. But anyway, so good old-fashioned AI operated on the assumption that the mind is like a computer and you could build a genuine full-blown mind on a computer using math and logic. that was the view. So this starts kind of before there was even computers. Alan Turing wrote a chess program, a program that could play chess before he had a strong enough computer to run it. He just did it with pencil and paper. So the good old-fashioned AI approach to AI, as soon as there are electronic computers, people are pursuing this. And it kind of comes up all the way today. So people are still writing AI programs that do logical mathematical manipulations of language-like symbols. So it's not like it went away. But what we'll see is that a lot of the problems that we identified with kind of language-like processing in the psychology section are going to come back and make problems for the GoFi view of AI. So stuff like combinatorial explosion, stuff like not knowing what the right representation of a problem is, that kind of thing. And in some sense, the Newell and Simon project was precisely a good old-fashioned AI project. So we've sort of seen a bit of this already. So we're going to talk a little bit about GoFi. We're going to talk a little bit about the assumptions it makes, the kind of metaphysics of mind that it assumes. And we're going to watch it not really work out all that well. So by the 1970s, 1980s, it was fairly clear that this was not going to be a straightforward path to artificial intelligence. People don't really, like if somebody's trying to build a mind, they don't really use this approach anymore. So by the 80s, by the 90s, people started switching to the next kind of big paradigm in AI, which was connectionism. Connectionism is AI organized more like the brain than like a computer. So this is a neural network. Each of these things are nodes connected to other nodes, and you put in inputs and it outputs some signals. And it's broadly, in a very broad way, organized more like the brain is than a computer. They ran these things on computers, which is an issue that we'll talk about quite a bit. So it's about the implementation of this thing, or sorry, it's organization rather than how it's implemented. But these things turn out to be really good pattern recognizers. So if you've got a object character recognition program that takes like a scanned document and turns it into a searchable document, it's using something like this. The issue here is that these things are going to turn out to be really only good at specific tasks. So you build a neural network, you train it up on some data, and if you trained it up on object character recognition data, it's going to be really bad at doing something else, anything else, like faces or trying to figure out what animal's in a picture, right? They're really specialist systems, and there didn't seem to be any way to make them into what we are, which is general reasoners. So we pursued this for a long time. I mean, I was a kid at the time, but people pursued the connectionist framework for quite a while. We saw a lot of big improvements, but it kind of hit a wall when we found that there's no way to transition this from specialist problem solvers to general thinkers. So we'll look at the kind of rise and fall of connectionism. Fall of connectionism is probably too strong because people still use all kinds of these things in practical applications. So these are incredibly useful structures, but it's just not clear how to roll these over into a theory of how our minds actually work. Then finally, we're going to look briefly at the dynamical systems theory. So connectionist networks are in some sense a certain type of dynamical system. Dynamical systems theory is a more general framework. Very often they use stuff like sets of differential equations to track how a system would change over time. We're going to talk more specifically about self-organized systems. I showed you an example just before the test of a self-organized system of those metronomes syncing up. So that's a very simple form of self-organization. And then we're going to speculate, well, I'm going to speculate, that there might be some specific types of self-organized dynamical systems that could solve the problem of relevance. That is, maybe we can come up with a picture of how minds dynamically self-organize that can help us deal at long last with this problem of relevance that I've been kind of hyping up the whole semester. Okay, so that's broadly where we're going to go, and this is going to sort of smoothly transition into issues of philosophy of mind, which is the third half of the course. We'll talk about experience and consciousness, and what is the mind anyway. And a lot of what I'm going to do today is kind of set up for that. So if that's any questions so far. Okay, so this is going to be a weird one. It's going to be an odd class. I'm going to tell you a long story. And it's not going to be until the end where it's sort of at all clear how this connects up with cognitive science in general. Just a quick note, we're on to, in the readings, we're on to this book by Joel Walmsley, Mind and Machine. It's a really good book. Does anybody know if this is in the bookstore now? It should be. I ordered it some time ago. It's also online, so if you can't get to the bookstore or it's not in the bookstore, you can look it up on the U of T library system and just read it online. Yeah? It's very readable. It's not, so this is written, everything that I've given you to read so far has been like pretty challenging primary sources from cognitive psychology, like fairly challenging stuff. This is written as an introduction. It's written sort of with a class like this in mind, so should be more accessible than the stuff we've done so far. Please do check it out. I'm not sure how tightly the classes overlap with the recommended readings for each class. So I've recommended you read the first 6 chapters, and we will broadly be following along with Walmsley. I think he took this class. He was at U of T. I think he took this class long ago. But go ahead and read this stuff. It's a helpful supplement to the stuff we'll be talking about in class. Okay, so we're going to do today the prehistory of AI. And I mean prehistory, like we're going to go way back. So we're going to trace out the scientific, philosophical, metaphysical issues that lead up to the very idea of AI. And I'm going to make the case that this is a very old idea, in fact, that you can see the beginnings of AI, thinking about AI, especially good old-fashioned AI, in the scientific revolution. So that's pretty far back. I'm going to argue that you can see it in Hobbes, basically. But I don't know how much history of science you've all done, which means that in order to understand what's going on in the scientific revolution, you need to understand what it was a revolution against. So to give the context of the scientific revolution, we need to do the prehistory of AI, which is it's pretty early stuff. I'm going to start with Aristotle. Yeah?
Question about the scientific revolution, is it kind of a nailed down period at which it happened? Dates you kind of give us?
No. No. The answer is no. There's not historians of science are very reticent to say that there is a specific period. And one famous book on the scientific revolution says there was no such thing as a scientific revolution. This is the kind of thing that historians do. And this is a good, so just by way of warning, what I'm going to do with you today is history. And we've got a couple of hours to do it in, and I would be totally embarrassed if any of my historian friends were in the room today, because they like to do things really carefully in a lot of detail and without extracting generalities from it, which is all of the things that I'm not going to do today. So we're going to act like really bad historians today. And I'm going to say a bunch of things like, Descartes came up with this idea. And the reality is there's probably a dozen people around who also had similar ideas. It's a big conversation, and I can only give you a tiny little slice of it. I hope that you don't mind me radically simplifying this for the sake of being able to present it in just a couple hours. Just to note that I'm doing that. So I'm radically simplifying an enormously complex history, just picking out some highlights, using some people as representatives of large movements and that kind of thing. So I'm not giving you the whole story. By the way, I was doing that with the history of psychology as well. So when you get into doing research for your essays, you'll find that the story being told in the primary literature is substantially more complex than the story I told you. I am trying to help by giving you the simpler version of the story, giving you a way into this stuff. You don't want the complete story. That would be too much. So we've taken a perspective on this stuff. Anyway, okay, so the thing that I'm going to set the scientific revolution against, so I want to tell you some stuff about what happened before the scientific revolution, and basically I'm going to start with the Aristotelian worldview. So Aristotle. We've all heard of Aristotle? We've all at least heard of Aristotle? Okay. So Aristotle was an ancient Greek guy. He lived several centuries before the Common Era. and he's one of the most influential thinkers in the history of the world. So the scientific revolution comes along in Europe and overthrows the Aristotelian worldview, which is why to understand the scientific revolution, you need to understand some stuff about Aristotle. So, and here's basically here's going to be the gist of the story. Here's the thing that's going to shift in the scientific revolution. In the scientific revolution, we get a new understanding of the relationship between meaning and purpose and reality, the world. In the scientific revolution, something really dramatic happens that doesn't probably feel dramatic from this perspective of people sitting in a classroom in the 21st century in Canada, which is that the world itself loses intrinsic meaning. So I'll show you that in Aristotle, the world is just pulsing with significance, meaning, purposes, goals. It's just filled with that stuff. And that's by no means unique to Aristotle. Practically every culture that I can think of throughout history has had a view like this. Like if you look at ancient Chinese philosophy, there's frequent references to the will of heaven. So the will, you can tell whether the emperor, so this is a great sort of preoccupation of Chinese scientists. You can tell if the emperor has the mandate of heaven, that is, that the world agrees with what the emperor is doing, if astronomical and weather events are happening regularly and predictably. And if something weird happens in the skies, that's a signal that the emperor has, his grip on heaven's blessings is slipping. Right? So they worked really hard to do things like predict eclipses. Right? So correctly predicting an eclipse is evidence that the emperor still has the mandate of heaven, which means that the world itself has views about how things should be going. It's built into the world. You see this in ancient Indian philosophy. So in Hinduism, there's this notion of what am I? What's my most central selfhood is Atman. And what is that really? Some schools say that that's Brahman, which is like a world soul. So the world itself has a soul. It has kind of like a perspective. It has a mind, in some sense, a mind, not like our mind, but like a cosmic mind. And your mind is a reflection of that kind of world mind, world soul. Yeah?
Can you give us an example kind of in Aristotle's?
Give me a minute.
Like,
Give me a minute.
you talk about the world of like.
Yeah, I'm going to do that. Yeah, yeah. Okay, so practically every culture for practically all of history had a view of the world where the world had meaning in it. It had purposes, goals, and values built into the structure of reality. And then in the scientific revolution, for kind of specific cultural reasons, that goes away. And we get this view that most people that I hang out with anyway don't think that the world has purposes built into it. They think that the world itself is in some sense meaningless and that we are this unique being in the universe because we have goals, we have values, we apply meaning to the world. So the story I'm going to tell you today is in some sense a story of deep, deep loss. We've lost the sense that we are connected to the meaning of reality, that we generate meanings for ourselves. And that is going to actually set the project of artificial intelligence, and B, the main problems for artificial intelligence, which, to preview the conclusion of this, are going to be to figure out how you get meaning and purpose and values out of a purely mechanical process, which itself has no meaning or purposes or values. So that's where we're going to go today. That's why I'm telling you this story. Okay? Okay, so let's dig into the Aristotelian worldview. Okay, I'm going to tell you about Aristotle is super prolific, so I'm just going to give you like two little bits of it. He writes on absolutely everything, but I'm going to tell you about his theory of natural motions, which is basically his physics, how his picture of physics works, and then his theory of how knowledge works, which is the conformity theory. Okay, so here's his theory of natural motion. This is Aristotle's physics. This is basically the Aristotelian universe, or the universe as Aristotle thought of it. You've got, of course, the Earth in the middle, a little layer of water over it, and then a layer of air over that, layer of fire over that, and then you get the celestial bodies, the moon, the planets, the sun, and then sort of like the stars as a halo around that. Recall when we talked about categorization, we talked about definitions and essences. Do you remember that? So Aristotle had this view of concepts that says your concept is a mental definition with a set of necessary and sufficient conditions, which is an essence. So Aristotle doesn't just think that that's a view about concepts. He thinks that things themselves have essences. And if you want to know how something's going to behave, the way to do that is to learn about its essence. But you don't only learn about how it does behave, you learn about how it should behave in some way. So here's Aristotle's story about why rocks sink to the bottom of lakes. The proper place for things, he's working on a 4 elements theory, so earth, air, fire, water, or sorry, 5, and the ether, which is what the stars are made of. So everything that we deal with is earth, air, fire, and water. Earth has a proper place, which is at the bottom. It's in the middle of the universe. So why do rocks sink? Because they want to get back to their proper place. They like that. They like being in their proper place in the universe, and their proper place is defined by their essence. So rocks sink because they are seeking their proper place in the universe. They have a goal to get back there. Water sits above rocks. That's water's proper place. Air is above water. Fire, when you light a fire, it goes up. Why does it go up? Because fire is trying to get back to its proper place in the universe, which is above the air. So this is, I mean, it's more complex than that, but that's basically Aristotle's physics. And you can hopefully see that this is a physics that's quite unlike ours. There's no math in it, for example. Aristotle thinks that everything under so this is the celestial spheres. Math applies very nicely to the celestial spheres, where everything is perfect and undisturbed. But in our kind of messed up, like bottom of the barrel place in the universe, everything's too mixed up to do math on. So you can't do math physics based on math, because it's all too jumbled up and it's all moving around. Very briefly, he's got this picture of 4 causes. So if you want to understand why anything is doing what it's doing, you should understand it in these 4 ways. The material, what it's made of, the efficient cause, that is whatever kind of pushed or pulled it into its place. Efficient causes is the only thing that we mean by cause now. So if you say what caused this to happen, what you mean is what is the efficient cause, or that's what Aristotle would understand you to mean. The formal cause, that is the shape of something, and the final cause, its purpose. So the material is just whatever it's made of. For Aristotle, everything is the union of matter and form. So everything has a form, so the word form doesn't really mean what we mean by form. It's something more like the ides, so the structural functional organization of a thing. So let me go back to this. So the pot is made of some material, clay presumably. The efficient cause is the person who actually shaped it and fired it, right? They're the person who actually like pushed and pulled the material into its shape. The formal cause is the form of pottery, or the form of chair, or the form of whatever it is you're talking about. And the final cause is its purpose. So if you want to understand, for Aristotle, if you want to understand anything, you have to understand it in all 4 of these ways. And what we're going to cut out of that in the scientific revolution is everything except the efficient cause. So we're going to lose 3 of these causes as not real causes. We're just going to leave efficient cause. Okay, so this is his view of physics, basically, how he understands natural motion to work. This is the briefest possible presentation of this stuff. I'm sorry if it's a bit vague and confusing. I'm sorry. I don't know how to present this very briefly without kind of skimming over it. Any questions so far about Aristotle? Yeah.
So we removed ourselves kind of out of the scientific worldview
Yeah.
with the scientific revolution. Are we not just kind of regressing a little bit by trying to put ourselves back in it? Like, what was,
Well,
I guess, the goal of cognitive science and kind of a naturalistic comparative?
are we regressing? Well, we're not going back to Aristotle. It would be regressing if we gave up progress that we'd made for the sake of recovery. So if you're like, boy, I miss final causes, I miss the world having purposes, here's what I propose. Chuck out all of physics and modern science and just go back to Aristotle. That would be regressing. The point is to not regress, but to recover some stuff that we lost. Yeah?
Will we be able to do, like, one of the things that, like, the naturalistic comparative reason is how do we fit ourselves into the scientific paradigm, but what if the scientific paradigm, I guess, is incompatible with it? Like, are we allowed to change the current scientific paradigm to fit ourselves into it?
Well, our current scientific paradigm is changing all the time. All the time. And in fact, I'll make the case later for you that formal causes are coming back. And they're coming back through dynamical systems theory. So trying to understand complex self-organizing systems brings back formal causes and maybe sometimes final causes. Actually, biologists never stop talking about final causes. Biologists at no point like even eased up on talking about final causes. What is the heart for? It's for pumping blood. Like that, they've always talked, why does a bird have wings? What are wings for? They're for flying. Like biology has never stopped talking about final causes. Yeah?
Are final causes always
Singular?
Yeah, maybe multiple for one object.
You can have multiple final causes. You can have multiple final causes. Yeah.
And so if I start defining random ones for an object, are they still considered final, or would they be?
Okay. So you can talk about purposes which we have for objects. In Aristotle's view, these objects have these purposes built into them. They're in the object themselves. They're a fact about reality rather than something that we apply to it. So you can certainly decide to have a purpose. You say, this pot is now a weapon, I'm going to smash my enemy with it, right? So that's applying a new purpose to the thing. But for Aristotle, it's not kind of built into the pot. It's not something that it has, whereas he would say, my heart is for pumping blood, and that's not something that I don't even need to know I have a heart for that to be true. It is just a fact about me. Yeah. Yeah.
Do these have to be, like, are they in any kind of like specific order? So if I change its
No.
final, it won't change its formal?
No, they're not. It's not in an order. No, all four are necessary for really understanding something. Okay. So that was his theory of natural motions. It's a theory which says everything acts the way it does because of these four causes, and at least part of the story of why anything does what it does is because it's seeking its proper place in the universe. And it's doing that because of its essence, what it is really. So things act according to their essences, right? That's the form that has been applied to the matter. Everything is a union of form and matter. And that makes causes kind of necessary. So if I say the rock falls down, that's not just a coincidence. That's not just something the rock happens to do. It's a necessary feature of the rock, because the definition of a rock is something made of earth, and the essence of earth is to seek its natural place. So it's kind of a necessary fact about rocks that they fall down. It's a necessary fact about fire that it goes up. So these are sort of really tight, powerful causal connections. Okay, now that's his theory about physics. Let's talk a little bit about his theory of knowledge. So he has what's called the conformity theory of knowledge. Here's how he thinks that you know things. Suppose you've seen a bunch of chairs. Now you understand what those chairs are. You get chairhood, right? Imagine that you could be so advanced as to understand what a chair is. Now, he thinks that, so different chairs have basically different shapes, right? So that's why you don't want to say that the form of a chair is just literally its shape. It's more like the structural, functional organization of a chair. You get the idea that it's supposed to have sturdy legs and a flat seat in order so that you can sit on it, yeah? So that's why its parts are put together in the way they are so that it can fulfill its function, okay? So that's the form. A form is like the structural functional organization of things. Every physical thing is a combination of matter and form. And what happens when you know something is that you literally have the form in your well, okay, so I put a picture of it in its head. They thought the seat of the mind was the heart, actually, in ancient Greece. So somewhere inside your mind, the form of the thing is literally in your mind. You conform to it. So this is a really intimate, direct knowing of the world. When you know something, you actually have a part of it inside of you. Yeah? You're in very direct contact with the world. This is Aristotle's view of how we know things. You see the form that's shared between all of the different instances, and that form is in you. So you're in direct contact with reality, and that form is the essence of the thing. The essence tells you about the necessary causal connections. So this is a very deep, so this is kind of a very, I wish I lived in this world. I really do. Because there's a really nice tight fit between his theory of physics and his theory of knowledge. And they afford us a really common sense, comfortable place in the universe. The universe is the way it appears to you. So when you're standing outside, it looks like the sun is going overhead. Guess what? The sun is really going around us for Aristotle, right? It seems to you that the world is thus and so, and it is, right? So we've got a really nice conceptual package here. It affords us a really clear picture of reality. It makes a bunch of predictions. Look, every time fire goes up, it confirms Aristotle's theory of motion. Every time rocks fall down, that confirms Aristotle's theory of motion. So it's got tons and tons of evidence, and it actually provides a fairly decent paradigm for doing natural scientific research. So when you're trying to understand a thing, you try to understand its essence. You try to understand the thing that's common between all of its instances, and then you extract that essence, and then you get it. So this is a really nice package of ideas, and a profoundly enduring one. Yeah?
Kind of getting back to memory, how memory can be like mutable, and how you more or less memorize meanings. Would these IDs or EDs, how do you pronounce it?
Yeah.
Be like a meaning and kind of just with respect to functional?
So I think that undersells the metaphysical dimension of the form for Aristotle. So a form is not just something that is not just an idea. It's literally what gives shape to objects. Like it's a kind of inner principle of objects that's in them, in the world, right? So there's a shared something between. So one example is all the different red things. You could have either one of two views about all of the different red things. Either there's just a bunch of red things, or that there's something universal shared between all of them. And that's a fact about all of them. It's not a fact about our ideas or opinions or what we assign to it. It's just in the world. And so Aristotle's, the form is literally part of the thing in the world, whether we know about it or not. So calling it meaning, in the modern sense of meaning, kind of makes it sound like something we're putting on it. But for Aristotle, that stuff is in the world. And then we observers participate in that thing when we know it, we're participating in that thing in the world. Okay. Well, you come up with a theory of the world that lasts for 1,000 years. This is a whole, I'm gonna breeze over this stuff because you can spend your life studying this stuff. So if that's all, the main thing I want you to get here are two things. The tight fit between the conformity theory and his theory of natural motion. So essences tells you what the necessary causal connections are between things, and that you grasp the essence by participating in it. Okay? And Essences also tell you what the purpose, the proper place of anything, the goal of anything is disclosed by its essence. Yeah?
So is he saying, like, I guess, kind of the chairs having like a fact, and that's just, they are a fact of existence, and this is just a thing, I
So-
give me the analogy of, if I was a conscious chair, and I decided that I'm just a chair, and this is just my essence, I'm gonna structure and organize myself like this. When a person perceives that, they're understanding part of my decision to be chair-like.
Yeah, we don't want to make it too mental, so the form is not like a mental thing for the chair. It's just it's inanimate, but it nonetheless, yeah, you're getting what the essence of chairs are. I mean, I take it that with artifacts, we have no problem with this idea that they have a purpose, right? You build a chair for, that's why they build chairs the way they build them, for sitting on, right? It's that. And so we're really comfortable with this. And Aristotle's just doing this thing where, I mean, with many, many aspects of his worldview, he's just saying, look, the way the world seems to you is the way the world seems. So I see a bunch of stuff that was made for a purpose. Everything's made for a purpose, right? Artifacts, living things. And he just says, okay, we'll just take this thing that we know about artifacts. You can really easily interpret living things as having purposes. Why does my heart beat? For pumping blood. He says, well, that's just what the whole universe is like. So the way the world seems to you just is the way it is. Yeah?
But isn't that not the case? Aren't there things that seem to be one way, but they're really another? Right? Like the example would be, if you're playing peekaboo with an infant under the age of 2, like they don't have a sense of object permanence. So you actually disappear.
I agree. And Aristotle lays out a couple of conditions under which your senses can fail you. So you can have malfunctioning sense organs. So if you're drunk, maybe you didn't see it right. If you just went to the Eleusinian mysteries and did whatever they do there, maybe you're hallucinating, you're not seeing right. Maybe the medium is weird. So if you're in the desert, you see a mirage, that can fail you. And sometimes it's just you. So you should check that your organs are working right, your sense organs are working right, the medium through which you're seeing things is working right, and then ask a bunch of people, get consensus about what's happening. And if those 3 things are met, Aristotle thinks, then you've got reliable knowledge. But of course, we can look at the sun. I mean, you're right. Of course you're right. Of course you're right. So this is why we shouldn't be Aristotelians. You can look at the sun, and everybody goes, yeah, I mean, I'm seeing that fine. My eyes are working fine. I'm sane and sober at the moment. It looks to me like it's going around. What does it look like to you guys? And if this was before Copernicus, you'd all be like, yeah, it looks like it's going around. So therefore, according to Aristotle, that's good evidence that the sun goes around the Earth. So yeah, I mean, this is one of the main points we're going to get to today. So yeah, okay. So Aristotle sets this going. This continues for it's not just him, it's this whole research program that comes out of his way of this really nice conceptual package that he puts together. And people continue on in this Aristotelian fashion for 1,000 years. Less so in Europe, Western Europe. So Aristotle was big in Western Europe for a little while, and then they kind of lost the knack for reading in some sense. Things went really badly so the Western Roman Empire fell, and things went really poorly in Europe for quite some time. But of course, Europe is not the only place in the world. So while Western Europe is falling to bits, a series of Islamic caliphates are organizing themselves. This is the extent of the Abbasid Caliphate, just to show you how massive this organization was. So the Islamic world gets really interested in collecting and translating learning. So the Abbasid Caliphate in particular, they have this political problem of they've just taken over a very sizable portion of the world in not that much time. And they're not imposing Islam on these conquered cultures. They're using a model that they picked up from the Romans, which the Romans picked up from the Persian Empire, which is you take over the joint, and then you let people keep their culture, and just so long as they pay taxes, you're fine. And in fact, Islamic people paid slightly less tax, so you're kind of discouraging people from taking up Islam because like you need the tax revenue. So they've got this cultural problem of how do you keep this enormous, sprawling caliphate kind of culturally coherent without squashing the cultures that you've just colonized? And one of the answers, they got a bunch of answers, but one of the answers is to make Arabic the language of learning in this part of the world. So they spend huge amounts of money collecting all of the knowledge from throughout the caliphate, bringing it a few different locations, but one of the central ones was Baghdad, translating it all into Arabic and paying like really high, like, so one story said, an Abbasid caliph said, if you bring me a book that I haven't got in my collection, I'll give you its weight in gold, which really encourages like wide margins and big handwriting. But so they are collecting knowledge, they are bringing it together, and Aristotle is at least part of this. So during this period, they're paying for a lot of collection of ancient knowledge and development of new knowledge in the form of, they're working on logic, science, chemistry, medicine, astronomy, like all of the normal fields of study that you would imagine. And Aristotle is a big part of this. So I'm just gonna, just as one example, this is again that warning that I gave you about like skipping over stuff. This is a humongous, complicated story, but in this period, Aristotle's, this is where I would start to point to the kind of the breakup of the Aristotelian worldview. So I want to pick out one person in particular, AlGhazali. So AlGhazali is one of the most famous critics of the Aristotelian worldview, and he gives us this really interesting argument that I want to present to you. So AlGhazali was really interested in philosophy, studied a lot of philosophy, but kind of got stuck in a skeptical downward spiral. I don't know, this happens to people who study philosophy fairly regularly. They start asking, well, how do I know this? How do I know that? How do I know anything? Oh no! So AlGhazali got into one of these things to the point of being incapacitated. Like he was literally incapacitated by philosophy, which really does happen occasionally. He seemed to have it real bad though. And what brought him out of it was a kind of mystical revelation in the sort of like Islamic Sufi style. So he's a committed Muslim, but he's still deeply engaged in philosophy. So he writes this book called The Incoherence of the Philosophers. And it's a cutting critique of the attempt to merge Aristotle with Islam. This is going to be an ongoing problem throughout. So they got all this great knowledge. They got Aristotle, who's huge, and Aristotle's research program, which is hugely helpful, like tons of good stuff in there. And of course, a deep commitment to their religious tradition. So there's some people trying to put these two things together, and it generates some tensions. So one of the tensions, for example, is Aristotle's view that causal connections are necessary. They're necessary because it's the essence of the essence of a rock is to want to fall down. So rocks want to fall down. But what about when God wants to do a miracle? This is worrying to them, right? So there's various records of miracles in the Quran and earlier books. So what about that? Doesn't the necessity of these challenge the power of God? This is a thing that'll be taken up later again in the Christian tradition. So they've got this tradition of rational theology and this tradition of natural science, and there seems to be some tensions. So AlGhazali, motivated by this, but it's nonetheless an argument that we even you can appreciate without kind of worrying about the theological dimension. AlGhazali says, what makes you think these connections are necessary? So his main example is lighting a bit of cotton on fire. AlGhazali says, look at your evidence for the necessity of this connection. What makes you think that this connection is actually necessary rather than just something that happens a lot? All you ever see is one thing happening and then the other thing happening. I put a match to the cotton, it lights on fire. All of your evidence is just of their connection. none of your evidence shows that the connection is necessary. And if you studied some philosophy, you're probably thinking, hey, that sounds like David Hume's problem of induction. And it's the exact same argument as David Hume's problem of induction, which Hume will get very famous for several centuries later in Europe. So this, I pick out this argument because I think it's a really important one for prying apart the Aristotelian worldview. The two parts of the Aristotelian worldview, where for Aristotle, when you know something, you participate in it. That is to say, there's no distance between your senses and the world. Your senses are delivering parts of the world into your mind. Whereas the kind of skepticism that AlGhazali presents drives a wedge between your senses and the world. It says, what's your actual argument, you philosophers, for having this direct sensory connection to the world? Why can't we be fooled by our senses? And they didn't really have anything good to answer them with, right? All you ever see, when you see one billiard ball hit the other and it zooms off, you don't see the causal connection. You just see one billiard ball stop and the other one start to move. That's all your senses deliver to you. And if your evidence is from your senses, then you don't have evidence that that's always going to happen. So this kind of causal skepticism pries apart the metaphysical and epistemological parts of Aristotle's worldview. It says, no, maybe your senses don't just deliver the world directly to you. Yeah.
I don't remember this properly, so I might be like a little off and I appreciate if someone can.
Sure.
But there was this thing I studied about where there's like white swans, and then
Right.
what if you see a black swan and then you're like, my conception of swans changed.
Good. Yep.
Is it like kind of related to that?
Yes, it is. Yes, it is. So this is the classic philosopher's example of induction. So induction is where you say, you try to make a series of observations and then infer from that a rule. So you see, I've seen 150 white swans. I went out into nature and I observed all the swans I could, and all 150 of them were white. Does that prove, the question is, does that prove the universal claim, all swans are white? And the answer is no, because it's always possible. Does it prove it beyond a doubt? The answer is no, because it's always possible that you'll see a black swan. It's a hilarious example because the people who come up with it lived in Europe where all the swans are white, whereas in New Zealand there's a bunch of black swans. So it really was the case that if they just went a little further, they would have found an example that showed that their rule was incorrect. So this is exactly the kind of thing that AlGhazali is worried about. So he thinks, yeah, I've observed. So Aristotle thinks that, or he thought, he's long dead, but Aristotle thought that you could look at the world and kind of extract the universals from it. So that there's no, for Aristotle, there's no problem of induction because you're just seeing things and like your mind absorbs the form of them, which tells you about its necessary connections to other things. But AlGhazali's skeptical argument and asking us to attend to the actual evidence we have available shows you that you have to worry about induction. You have to worry about that 151st black swan because you're not just metaphysically sucking the forms out of things. You're trying to extract patterns from the world. And guess what? AlGhazali's way of thinking about this is way better for doing science than Aristotle's thing, where you don't assume an intimate connection between your senses and the world. You don't assume that the world is faithfully, just because you're not drunk and your eyes are working, that the world is just going to disclose its secrets to you. You have to doubt yourself. You have to doubt whether the things that happen regularly happen necessarily. We've been talking about the kind of development of the Aristotelian worldview in the Islamic world, and then the kind of tensions that built up between it and the sort of rational theology developed in Islam, and the kind of beginnings. You can start to see the crack up of the Aristotelian worldview, the fault lines along which it will eventually burst asunder. Meanwhile, in Europe, things are going rather poorly. So the 14th century, the 1300s, were not an awesome time in Europe. For example, the bubonic plague just killed a third of the population. They had plagues all the time. This was one of the worst ones. So half or a third of the population dies. They call it the 100 Years' War from not quite 100 years. Catholic Church schisms, breaks into two. Really, all of their kind of basic social, political institutions are kind of falling apart at this point. So a few things result from this. When a third of the population dies in an agrarian society, that means there's a labor shortage. So all of the rich people get their money from skimming off the top of the farmers. So that's how you, as a feudal lord, you own the land, or you're rented the land from the king or whatever. So your wealth comes from the farmers who are working your land. A third of them die. That means that you are facing a serious labor shortage. And the kind of social strictures that kept people fixed to a certain plot of land for generations kind of breaks up at this point. And people notice that they can make a really good living by doing things like traveling around and trading. So trade really picks up at this period. And when you're trading, especially if you're trading via boat, you need things like really accurate astronomical tables. So there's an increased need for, hunger for, so they're navigating by the stars, of course, right? That's how you navigate back in the 13th century. If you're going to drive a boat, I suppose sail a boat, across the sea, you navigate by the stars. You do that by having an astronomical table that they calculate where the stars are supposed to be, and you figure out which direction you go from where the stars are supposed to be, right? So this is, I take it, this is how people travel around. Also, this travel drives lots of interaction with nearby cultures that might have, for example, preserved and refined the intellectual tradition, which you will, thousands of years later, claim that was yours all along. They do things like go on crusades and go ransack the East and bring a bunch of books back with them, including some works of Aristotle and the very idea of bathing regularly. A lot of important stuff being imported into Europe at this period. One of the things that gets imported is the number system that we all use. So this was developed in India and then taken up by the Arabic world, and then it gets imported around the 1200s into Europe. And I don't know if you've ever tried to do math in ancient Roman numerals, but it is a real hassle. It is a real challenge to use ancient Roman numerals to do anything. So during this period in Europe, things politically speaking, especially if you're at the top of the heap, are going really badly. You're moving around more, you're trading more, the kind of culture is opening up, you're importing all kinds of things, sometimes stealing them, and amongst those things are a number system, much more advanced mathematics than you're used to. You're importing things like much more advanced astronomical tools from China, amongst other places. China, India, and the Islamic world are way ahead of Europe in terms of astronomy, and Europe just developed this keen hunger for accurate astronomical tables because they want to sail around. So all of this is getting imported and centralized into Europe from the 13th century to the kind of 15th century. So here's the, if you want a date for the beginning of the scientific revolution, this is as good as any. For our purposes, this is the turning point, or one of the main turning points, especially vis-a-vis the breakup of the Aristotelian worldview. Copernicus. So using this recently imported number system, the math that goes along with it, the algebra, the geometry, the trigonometry, and a bunch of sort of improved astronomical tools, Copernicus works out that the math works better if you put the sun at the center of the solar system. Okay, so pay attention to the way I put that. The math works better. Gesundheit. So the Aristotelian worldview had it that the way that the universe looks to you is an accurate and reliable guide to the way that the world is. There was this beautiful, comfortable fit between the way that our senses present the world to us and the very structure of reality. Things like the sun goes around the earth. Copernicus comes along and says, hey guys, the math works better if you put the sun at the center. And take a moment to appreciate what a profound upheaval of your sensory experience that is. So I have currently the feeling that this ground is pretty steady. I have the sensory experience of staying still right now. And if Copernicus is right, I'm whipping around in a rotating Earth, which is whipping around the sun at unimaginable speeds. So, whereas Aristotle had a physics that didn't have any math in it, Copernicus is telling us, you should disbelieve your senses. Your senses have got it wrong. The math is the way to access the structure of reality. Mathematics becomes, increasingly from this point on, the accurate and reliable method for accessing the structure of reality, not your senses. Mathematics becomes the language of the universe. Side note, Copernicus wasn't the first guy. Aryabhata, the most famous Indian astronomer, was way ahead of this, but anyway. History's full of these little repetitions. Okay, so Copernicus, he says the math works better. He's right, his math works better. His model of the solar system is not fully developed. That is, he's still got everything moving in perfect circles. He's still got the little epicycles in case you're a history of astronomy buff. But it does work better than the Ptolemaic system which came before him. A little while later, Galileo starts using math in a very interesting way. So this is one of Galileo's representations of distance and velocity. So he's using geometry to represent the relationship between distance and velocity. Now, does anything about distance or velocity seem triangular to you? Is anything triangular about velocity?
Vectors.
Yeah.
Lots of vectors.
Yeah, okay, so but that's going past the Galilean turn here. Well, essentially it's a proto-vector. So again, it's using mathematics not just to describe what's in your senses, but to describe abstract relationships between things. So the use of mathematics here is precisely to go beyond what your senses can present to you. And this turns out to be a winning formula for centuries. By using tools like Cartesian geometry, the advanced mathematics that Europe has imported at this point, you can represent features of reality. You can do physics using math. And that's kind of the innovation that Galileo presents. I mean, so using math to represent the movement of the stars is very, very, very old. Like, as early as written records seems to be we're doing that. But using math to represent the physics of the terrestrial world is relatively new, and especially in this abstract formula. So again, what we're seeing is the breakdown of the Aristotelian worldview, the breakdown of the tight fit between sense experience and the structure of reality, and a rise of this notion that abstract mathematical formulas and logical deduction are going to be the kind of royal road to knowledge, the way to access the real facts about reality. Philosophers sometimes talk about this in terms of the distinction between primary and secondary qualities. So the primary qualities are the qualities that would be there if nobody was looking. if there was no observer. So I take it that this bottle has a certain mass, and it would have that mass whether anybody's weighing it or not. I'm picking it up, trying to get kind of the sense of its weight, but it would have that mass no matter whether I could pretend that it's 1,000,000 pounds, or I could not be paying attention at all. It doesn't matter. It's got that mass, so it's a primary quality. It's in the object. On the other hand, it's blue, but blueness, according to this, is a secondary quality. That is, if nobody's seeing it as, in a dark room, it's not blue in some sense. I know that it's, in some sense it is, but, or like the sweetness of honey, right? The smell of the air. What's in this air? This air smells really good. I love this campus in summer. It's great. The smell of the air out there is something that if nobody was smelling it, it wouldn't smell. It's just a bunch of molecules floating around, right? Those molecules have shape. They have form and structure, right? They have mass. Those are primary qualities. But the smell is something, if there's no smeller there, there's no smell, right? So it's a distinction between things that we experience from it and things that are in the object itself. A joke can be funny. It's not funny if nobody hears it, right? It requires an observer. So primary qualities are those qualities of an object that don't require an observer. Secondary qualities, typically we think of things like color, smell, the sound. Like for my voice to be a sound to you, you have to be hearing it. If nobody's hearing it, it's just vibrations in the air. It's not a sound as such. This separation of the world into primary and secondary qualities proceeds apace. As mathematics gets taken up broadly by the scientific community as the correct language for describing reality, the primary-secondary distinction takes on a bunch of importance. And the primary qualities of the world are precisely those qualities that can be described mathematically. If you can say it in math, then it's a primary quality. So I'm going to say, well, the sound is really here even if nobody's listening. What they would take that to mean was I can measure and represent the waveform of the vibrations even if nobody's translating that into a felt experience of sound. Something like that. So if you can say it in math, it's a primary quality. The number of things, that's a fact about them. Their weight, their size, their shape. Those are primary qualities of the world. All this stuff about, color and quality and all that stuff, that's stuff that we're imposing on them. So again, we're seeing this deepening of the divide between sense experience and the world itself. Okay. We're almost back to AI. Hang on, we're going to come back to the topic of this course very soon. Okay, so you can sum this all up in terms of what we might call the mechanical worldview. And this is kind of a deep presupposition of the scientific revolution. The mechanical worldview says the world is just mechanical in the sense that, sorry, that was very circular. The mechanical worldview says the only things in the world the only causes in the world are things pushing and pulling on each other. Matter excluding other matter. Right? The world itself has no purposes, it has no goals, has no meaning built into it. Right? So all of that stuff that Aristotle used to explain the world, everything except efficient causes gets stripped away. Now, we encounter the world as full of things like sweetness and good smells and bad smells and beautiful melodies and meaning and purposes and all that stuff. But none of that, according to the mechanical worldview, is in the world. So the world is, in some sense, dead. It's inert. Right? It just reacts. The world itself is not alive. The world itself does not have a view. It does not have a sense of itself. The world itself is just a bunch of little bits of matter pushing against each other. So that's the kind of basic picture, the mechanical worldview, which becomes an exceptionally productive set of assumptions for research. If you want to understand a mechanism, what do you do to it? You take it apart into its parts. You understand its parts, you understand how they fit together, and then you understand the mechanism. You don't have to worry about its wholeness or its purpose or any of that stuff. You just understand the parts and you're done. And that becomes really a powerful set of assumptions for understanding, well, the kind of things that they could understand in the 15th, 16th, 17th century, right? It's a really productive set of assumptions. Now, yeah?
Would that, like, kind of the, I guess, mechanical thing that's up there, would that extend to how the parts connect with each other? Or are we just saying that, like,
Yeah.
parts are pieced together and then this is
No, yes, you have to, with a mechanism, you have to understand how the parts are fitting together. Yeah, so how the parts fit together is part of the mechanism for sure. Okay. Okay, so at last, we're back ready to reconnect this stuff to cognitive science. So here's the inference. The world is just made up of mechanical stuff. Well, we're stuff. We're made of stuff. Therefore, we are just mechanisms. So Thomas Hobbes says famously, by ratiocination, which is an old-timey way of saying thinking, by thinking, I mean computation. And computation is just a mechanical process. So really just, and you can make an argument from this just from the basic assumptions about the world, what's in the world of the scientific revolution worldview, you get straight, there's a very straight line to this view. We're just made of matter. All that matter can do is mechanically interact. Therefore, everything we do can be reduced down to a set of mechanical interactions. Purposeless, meaningless, sort of like locally defined mechanical interactions. And there you have it. There's the inception of AI. Yeah?
So you know there's primary qualities which are, I guess, like innate within any like object or thing.
Yeah.
And there's secondary qualities which require observation, right? So for the sound analogy, it's sort of like sound can't exist without a transmitter and a receiver.
Yeah.
Right? So
Yeah.
sound doesn't exist until you have those two conditions. Could you then say that the observation of a particular thing adds like a level of complexity, right? Because if you look at that water bottle, for example, kind of random, but like you can infer like a whole bunch of secondary qualities to that bottle, right? Which is real to you.
Right.
Does that kind of what I'm basically saying is like, do secondary qualities exist? And then if they do, is that sort of like where like relevance and meaning are derived?
Yeah. So it's a good question. So the scientific worldview, scientific revolution picture of this is that the secondary qualities exist only in your mind. They are an interpretation your mind is producing of things that are ultimately grounded in the primary qualities. So you add this, in some sense, you're adding or constructing for yourself the secondary qualities. And you can see that by doing things like, if you put this blue bottle under the right lighting conditions, it would look gray or white or something like that. So the blueness isn't in the bottle, it's in something about the interaction between the environment and your mind.
But is the secondary quality a thing that exists?
Yeah.
I mean, what I'm trying to say is, what would be the primary quality of a secondary quality if we're gonna look at it as not something that's layered on top of?
So there's got to be some mechanical interaction between you and the world. So there's they were still working on theories of vision at this point, but there's some particle that goes from the bottle to your eyeball, and then something in you interprets that as blueness. But the particle itself doesn't need to be blue. The particle, there's not like blueness being transmitted from one to the other. The particle is just got, so the only things that they're willing to accept that exist in the world are shape and position, basically. Shape and position. So the particle that goes from the bottle to your eye has a shape, it has a changing position, it goes from there to your eye, but it doesn't have blueness in any real sense, it's just that it evokes the experience of blueness in you. Yeah? Yeah, yeah.
So if you had like a perfect mechanistic definition of the mind,
Yeah.
you could model it.
Yeah.
Would secondary characteristics become primary characteristics because you can infer what they would be when someone's not there?
You could, yeah, you could theoretically reduce all the secondary properties to primary properties. You could say for any secondary property, you could say, well, it's just this sort of mechanical process going on in the mind. Yeah, yeah, yeah.
To get back to that, like, this water bottle has like a black top.
Yeah.
Like, I'm perceiving this, I assign the value of black to it, but it's made of matter that just doesn't reflect a lot of visible light back into my eyes.
Right.
If I have a machine pointing at that, the machine can come to the same conclusion that it's not receiving a whole lot of other visible light. Like, is this black a secondary property to me if a machine can also determine that it's black? I mean,
Well, it doesn't have the experience of color, does it? It makes the same assessment, so it can predict what secondary quality it would evoke in you, but it doesn't have the experience, and the secondary quality is supposed to be an experience. Okay, I don't want to dwell too long on this primary-secondary thing. This is like, let's do, there's loads of philosophy classes we could do about this. Let's do the AI stuff, yeah? Okay, okay. So Thomas Hobbes basically just reads off the scientific revolution worldview and says, look, we're all just machines, we're all just mechanisms. That's what we think everything is. All matter is just mechanical. So we're mechanisms too. That means that you could build a mechanical mind. You could build a mind that's just mechanical. And please don't, okay, I put this in quotation marks, breaking my rule that you should only put quotations around exact quotes. Hobbes does not literally say he thinks we're just meat machines. That's I'm paraphrasing Hobbes. We're just meat machines, says Hobbes. And Descartes says, yeah, but meat machines can't think. You can't think because thinking means understanding. Understanding tracks meaning, the significance of what's being said. And that's just what you told me that isn't in the world. You just told me that there is no meaning or significance in the world. But thinking means understanding the meaning of what you're dealing with. It's not enough to just manipulate symbols the right way. You have to understand them to be thinking. So Descartes says, cool, you just proved that minds aren't in the world. Thanks, Hobbes. You proved it for me.
doesn't that bring up the question of Descartes? Are we thinking? Like,
So
prove to me that you're thinking, basically. Like, I
Des-
guess that's an issue.
Descartes takes it as the most obvious fact about us that we're thinking. He thinks that that's the starting point for all other knowledge about us.
Taking it as a given the basis of axiom.
That's right. Do you doubt that you're thinking?
Yeah, sometimes.
But not all the time.
Like, I definitely think it's good to question your own decisions. Like, I'm not certain of anything.
Right, right. Probably shouldn't be certain of anything, but Descartes finds it to be obvious enough that he's thinking, that he's reasoning, not just thinking, but reasoning, he's understanding, he's deriving meaning from the world. Like when his eyes move over a page of letters, they sing to him, right? They tell him things that he understands. And if meaning is excluded by the mechanical worldview, for Descartes, that proves that minds must somehow outstrip the material world. Yeah.
So Descartes is sort of thinking similarly to Aristotle with I obviously am thinking, I perceive that I am thinking, therefore I am thinking.
Sort of. He doesn't take it to be a sense perception. It's a kind of internal perception. I'm surprised by the pushback for the idea that we're thinking here. Classes very often give me delightful surprises. I didn't expect this to be a point of contention, but whether people think and understand the meaning of things. You're all acting like you think and understand the meaning of things. Very much so. But yeah, so that is, okay, so but let's just sort of say, okay, this is one way you can go. You can just deny that people are thinking and are understanding. That's one direction this debate could go in. Most people are going to say, no, I'm pretty sure that I think and understand, that I'm having experiences, that the world I encounter a world as having value and significance. Like, most people are on board with that. That is one way you could go in this debate. You could just be like, no, you're all just delusional. Your mechanisms are messed up and you think that you're thinking. I think that's a weird move to make in this debate, but it is one possible move. So, okay, so where are we? We've got this debate between Hobbes and Descartes, and this is going to be this is important for us. This is going to be important going forward, thinking about artificial intelligence. We're going to have to think about the challenge that Descartes issues to Hobbes, which is to say, if you're going to tell me that we're just machines, and by the way, that's exactly what the hope of AI is. AI research operates fundamentally on the Hobbesian view that you can translate everything that's interesting and important about our reasoning into mechanical processes, right? If you can put intelligence into a computer, computers fundamentally operate under mechanical principles, sort of like local, rule-governed mechanical principles. If you can put intelligence into a computer, then Hobbes was right. So any hope we have for doing AI research is the hope that Hobbes was correct about this, right? Okay. But Descartes' challenge is one that you're going to have to face up to. Like, you can't maintain hope for the Hobbesian picture without dealing with the Cartesian challenge. So let me just draw this out a little bit. So the paradox of mechanical reasoning. This is Descartes' challenge to Hobbes. This is the thing that Descartes says, listen, Hobbes, you got to sort this out for me or else you're not making sense for me. Reasoning is truth tracking, right? When you're doing reasoning, you're trying to evaluate the truth or falsity of sentences. Sound good? Evaluating truth requires understanding meaning. You don't know what's being said. You can't tell me whether it's true or false. But if the scientific revolution showed us anything, it showed us that meaning is not in the world. That was the whole thing of getting rid of Aristotle, right? That was the whole, like, getting rid of final causes, right? Reducing the world to the mechanical worldview. We'll see this in a bunch of different versions. We'll talk about this at some length. So if the mind is just a symbol manipulator, it's just a thing that takes in symbols, manipulates them according to rules, how is it possible that it nonetheless reasons, which is something that you need to understand the symbols in order to do? Paradox of mechanical reasoning. Yeah.
The universe itself be thought of the computer that's doing the symbol manipulation, and then our minds being products of that symbol manipulation?
I don't know. Maybe.
I guess my problem here is that we're made of atoms that make cells and organs and tissues, yada yada yada. And if I shoot myself, if I rip apart my brain, I'm not going to be able to think very much more after. At least I'm operating under that presumption.
We need bodies to think. That's right.
We need bodies to think. If if the universe or those interactions, mechanical interactions, give rise to the mind, why then does the mind need to have some kind of other thing, not evade those mechanical interactions?
Well, okay. So did you follow the argument that we presented? I thought I was just answering that question.
I guess my problem is if we're made of matter,
Uh huh.
and matter is truly a stupid thing, it's just a mechanical process.
Yeah.
Like, how can Descartes make the assertion that we aren't just stupid? We're not just
From the
very complex.
for him, it's utterly self-evident that I'm baffled by this notion that you don't think that you have any sense of understanding the world.
I guess to me, my understanding of the world emerges from the interaction of the universe, so the atoms and the molecules.
Yeah.
And all of the body. I
Yeah.
don't view that though as anything special. I don't view my understanding of the world as sentimental.
So here's the kind of we've got a fork here or a dilemma. On one hand, you can say, look, I'm going to give up on the idea that we are thinking, understanding beings. That's one challenge, one way that you can deal with the paradox of mechanical reasoning. You say, look, we're just not reasoners. The other thing that you can do is do what Descartes thinks we should do, which is to say, there's something more to us than just matter. So Descartes is a dualist. He's going to argue that we should accept the scientific worldview idea that the world is void of purpose, but then take the next step and say, and furthermore, we're clearly reasoners who understand. And then those two things together entail that you should say, no, the mind must be something more than just matter. Yeah.
I mean, isn't the first, in strictly material interpretation, kind of profoundly unscientific? Because that's saying that stars don't fit into what we think about the world, so I'm just going to ignore that they exist. There's something going on in here. If we say, I'll just ignore it and pretend it doesn't happen, well, it's something's obviously going on and you're just ignoring it. The fact that you can choose to try and ignore something, what's doing that ignoring?
Yeah.
And I would ask you, can you truly choose
Please.
to ignore something?
Please put your hand up before speaking. Yeah, you can't. I can't just have people jumping in. Yeah. So this hinges on a lot of questions that are probably too much for this particular session. We're just trying to get up to the notion of the paradox of mechanical reasoning, and it's good that. So, actually, I heard once somebody describe philosophy as being like a shoe salesman. Your job is not to convince the person to buy any particular pair of shoes. As a shoe salesman, you're not like, these are the one and only pairs of shoes for you. The job of a shoe salesman is to lay out the options that you have, tell them about the various qualities, and then the person can buy whatever they think is correct for them. So if we get the different options in the debate, so similarly the job of philosophy, if this person is right, is really just to lay out the different intellectual options available to you. So if you're inclined to say, yes, I'm willing to give up on the idea that there's anything going on behind my eyes in terms of understanding them and experiencing the world as meaningful, that's one thing that you could do. I think that has profound cost because, I don't know. For me, I'm with Descartes on the idea that I just find it irrefutable, undeniable that I'm experiencing the world as meaningful and that I'm reasoning about it. I can't wrap my head around the idea that I'm not doing that. If you can, then that's the pair of shoes for you. If you, on the other hand, find the mechanical worldview so compelling that you can't deny it, but also find the idea that your reasoning so compelling that you can't deny it, then maybe you want to go the Descartes route. If we're going to do AI, if you're going to do any kind of AI research, you have to reject both of those. You have to say, look, we're just made of matter, but that matter thinks and reasons. So you have to resolve the paradox of mechanical reasoning somehow. Right? So if you're motivated in, believe in the idea that you can build a mechanical reasoner, you have to say, somehow this supposed paradox is not really a paradox, that there's some resolution to it, such that you can understand how merely material things can nonetheless give rise to thinking and feeling and experiencing. Yeah? Yeah.
Couldn't you just switch understanding meaning for reasoning and truth tracking? So instead of reasoning and truth tracking being dependent on your ability to understand meaning, couldn't you just say that understanding meaning allows you, it's like a tool that allows you to like find the truth? It's like more or less, I don't know where I'm going with this. It's instead of arguing that like to find the truth you need to understand meanings, but meanings don't exist. It's like, okay, meanings don't exist in the universe, but if you can invent meanings, now you have the tools to actually find the truth.
So this actually, the paradox doesn't actually hang on whether there's meaning in the world or not. It's just the fact that, you can still get the paradox if the world is meaningless. Actually, the paradox comes from the idea that the world is meaningless. So the idea is, like, we, for many of us, it's clear that we experience meaning.
Yeah, so what I was trying to get at.
Oh, okay.
I had like a.
Okay, come again.
It's instead of like thinking is in effect a function of understanding meanings, not the other way around. So you don't think, thinking doesn't allow you to understand meanings. Understanding meanings allows you to think, and so therefore understanding meanings is like something that we invent that allows us to do this cool thing called thinking, which then allows us to like find truth values.
So I think that still lands us in the paradox, because somewhere along the line you got that we're tracking truth and doing and understanding meaning, and it's a property of mechanical processes that they don't seem to do either of those things. I mean, it's not so. They don't seem. Let me be very precise here. They don't seem to do either of those things. It's not obvious how they could be made to do either of those things. The hope of the AI research project is that they somehow can be. It's only a paradox because it looks hard. It looks impossible. But lots of things that looked impossible turned out to be possible. So it's a It's just the problem of understanding how you can get a mechanical system to do something about truth and meaning. And if we can figure out a way of doing that, then we've got AI, something like that. Is that? Yeah. Yeah. Okay. So we're going to talk a lot more about this. So if there's unresolved questions, that's cool. We can come back to it. Here's another version of this. The problem of qualitative experience. So I take it we're all having experiences at the moment. None of us are so asleep that you're not even dreaming, right? Seems weird that you can attribute that to a mechanical system. How can something purely physical have subjective experiences? That seems odd, right? It's at least difficult to explain, right? I'll propose to you that nobody currently has a rock-solid theory of how this works. There are theories. We'll look at some of them, but this is like a big open question. If you're going to claim that the world is full of nothing but dead matter, ultimately, like atoms which don't have a kind of life of their own in some sense, then you need to explain to me how it is that I'm having subjective experiences and you're having subjective experiences. There's something that it's like to be you. I take it that there's not something that it's like to be a chair or the bottle, right? As far as we can tell, those things don't have perspectives of their own. They don't have this lively inner experience. We have lively inner experience, at least while we're awake. So how does that work? And if you're going to build an artificial intelligence that's as awake and alive as we are, does it get to have subjective experience? Is there something that it's like to be that AI? How do you program that into a computer is the question. And that's, again, just a question that we just don't have an answer for. That's one of the profoundly frustrating things about this class is that we're dealing with questions that there just aren't currently answers for. So I can't be like, and here's the answer. I can be like, and here's the really difficult question. No. So again, this is a thing that kind of comes out of this conflict between Descartes and Hobbes. You kill the world. You kill the world in the sense that the world does not contain the kind of mental dimension that it traditionally was ascribed. Almost all of history, almost every culture experienced the world as vividly alive in the same way that we are, right? The scientific revolution comes along and says, no, the world is dead and inert. We're alive, we are conscious. And that leaves you with the question, where does that consciousness come from? And it's really, really hard. This is one of the hardest questions in science right now. Let me give you one more version of this. The problem of original meaning. Okay. This is particularly a problem if you're picturing the mind in the way that the good old-fashioned AI people picture it, which is as a symbol manipulator, like a computer is a symbol manipulator. So you got a book. The book has words in it. Those words have meaning. So far, so good, right? How did the words get that meaning? It's because somebody knows what they mean. Somebody meant something by them. They had a meaning in mind when they wrote them down. And then if you pick up the book and read it, it's meaningful to you insofar as you can figure out what they meant. Or invent your own meaning, that's fine too. Either way, the symbols seem to derive their meaning from something other than the symbols themselves. Right? It's somebody's mind is contributing meaning to the symbols. Okay. Now, if your mind is just a symbol manipulator, how do those symbols get meaning? Yeah.
We prescribe to us when we were taught as children. And the same thing goes for like the person who created the original meaning. They didn't have they just had maybe not even a system of letters, but a system of sounds and actions that they prescribe to the sound.
Right.
Which is then eventually, it
Right.
time, right?
So that's a good historical account of how the words that we use got their meaning. I think that's absolutely correct about the history of it. But the question is, how did they acquire meaning in a kind of, I'm tempted to say metaphysical sense. The question is not how did so all along that story there were people who understood things attributing the meaning to the symbols, right? So you say, by this symbol I'm going to mean the number 4. And the thinker are giving the symbol the meaning, right? So you're absolutely correct that words get their meaning through a historical process of cultural sharing and invention. As Thor said in Endgame, all words are made up. Right? It's the most profound thing in a Marvel movie I've ever seen. Okay, but the question for us is the problem of original meaning is now imagine that the mind that gave those symbols their meaning is itself just a symbol manipulator. Is just manipulating symbols according to formal rules, like a computer. Now, how did the rules in the computer or in the symbol manipulator in your head get their meaning? Yeah.
But again, isn't it just that they created it themselves? It's not necessarily that they had a meaning. It's just that they prescribed it to something else, gave it the association, and continued with it.
So,
for example, I don't know what a specific word might mean, and so growing up for 5 years, I could keep looking at the word book and think it's actually to you. Well, to you, I would think it's a chair, but to you, you know that a book is a book and not a chair.
Right.
But I have prescribed it to myself because I never learned otherwise.
Right.
Something else.
But again,
So I keep calling it
in the account you just gave me, there's always somebody who's grasping the meaning. And it's the grasping of the meaning that's mysterious here. The grasping of the meaning is the hard part. It's the part that, so I take it that your computer doesn't understand anything that's happening inside of it, right? So it's manipulating symbols like crazy, it's manipulating them all over the place, but it's not understanding them in anything like the way that you understand the contents of a text. You grasp the significance of it. You grasp the intention of it. So you write in a book the word chair, and in the book, it's not really just the book just lying there. It's not about anything. But when you read that, the word has what we call intentionality. The word chair refers to those things that we sit on, right? The word chair has aboutness. Where does that aboutness come from? Now, if your whole mind, top to bottom, is just a formal symbol manipulator, exactly like a computer, it's very unclear how those symbols inside the machine get their aboutness. Because it's always, in any way that we understand, so we perfectly understand how words in a book get their meaning, is that we, the understanders, grasp the meaning. Hopefully, I mean, with practice, right? With practice and cultural sharing, we're trained how to grasp the meaning of symbols. But it's we, the interpreters, who do that work, whereas what I'm going to show you starting on Thursday, the picture of good old-fashioned AI is that the computer accepts symbols and just manipulates them without understanding them, manipulates them without having any kind of grasp of it. It manipulates them according to formal rules. So that's the kind of problem of original meaning. Okay. So you can I'm not going to do this. This is an attempt at giving an account of the meaning of things, which I don't know. This is just a lame attempt at trying to, sorry, lame is not a good word. It's a bad attempt at trying to give a theory of meaning. So how does I'll do it real quick. Maybe the being caused by an apple gives my thought apple the meaning it has. So I see an apple and the word pops into my head, apple. So the causal relation is what gives it its meaning. But then, like, you know, why is it that this apple is the meaning that occurs to me rather than red or fruit? Which meanings occur to me? You know, like what caused the understanding of the meaning of the word for? Like, anyway, okay, so I'm loopy from philosophy, so I haven't got the juice to do this in any detail. Okay, so just in summary, so what we're hoping for from AI is that it's more than just like a really fun tool to categorize images or something like that, right? What we're hoping for, or at least what some people are hoping for, is that we learn to actually build an actual mind. We actually build something that's intelligent in the way that we're intelligent, that's conscious in the way that we're conscious. And if we're going to do that, what we need to do is, in some sense, prove Hobbes right. We need to be able to reduce intelligence just down to unintelligent mechanical processes. But we need to do it in a way that deals with all of Descartes' challenges. So we need to figure out a way of saying how you do things like, apparently we deal with the meaning of sentences, their significance, their importance. You need to figure out how we do things like have a subjective experience, how we do things like understand the meaning of the symbols that we're manipulating, understand their aboutness. So Descartes lays out these very serious challenges that any program of strong AI that purports to really be intelligent, are going to have to deal with. If they're going to prove Hobbes right, you gotta somehow show why Descartes' problems are solvable. That's the project. Okay. Okay, that was a lot. Let's call it a day. Next time we'll start on the not prehistory of AI, but the history of AI. Okay.